Hello everyone, today we are going to learn the first lesson in Unit 2, which is congruency. What's the meaning of congruency? If I have two squares like this, if you look to this square, you will see that are the same. You will look these sides are similar to this side are equal, all sides, all vertices, all angles look like equal. So if I get any two figures are equal like this, equal in length, equal side equal in length, angle equal in measure, so we say that these shape or these polygon are congruent, are the same, like you see this in mirror, in the same of everything, sides, angles, vertex, all these are the same. So we say that these polygons are congruent, are the same. Okay, so any two polygons are congruent if the first case, if their corresponding sides. What's the meaning of corresponding side? If I take this side, this corresponding in the another square will be this side. This is called the two corresponding sides. If I take this side, the corresponding side in the another will be this side. These and these are called two corresponding sides. If I take this angle, the corresponding angle in the another square will be this. This is the meaning of the corresponding side, corresponding angle, corresponding vertex. This vertex, the corresponding vertex in the another square will be this vertex. This vertex, the corresponding on the another will be this vertex. This is the meaning of the corresponding side, corresponding angle, corresponding vertices. Okay, so if I see that two polygons are congruent if their corresponding sides are equal in length, lengths. And number two, their corresponding angles are equal in measure. There is the two rules that if I see this in any two polygons, square, rectangle, hexagon, pentagon, any two polygons are congruent only if this 1 and 2 is good on these polygons. All sides are equal in length. All angles or corresponding angles are equal in measure. And vice versa, if I have all sides in any two polygon, if I have all corresponding sides are equal in length and also the corresponding angle are equal in measure, so I will say that these polygons are congruent, and this is the meaning of vice versa. The opposite is true. Congruent means sides are equal in length, angles mean equal in measure. And if I take the another side, if the sides are equal in length and the angle are equal in measure, so the two polygons will be congruent. Okay? If I have this polygon ABCD and another one XYZL, sides, the first side, if I take this side AB, the corresponding side in the another polygon will be this? No. Will be this? No. Will be XY. This side is the corresponding side of AP. So AP, the side AP equal to side XY. And if I take another side PC will equal YZ. Sorry, PC will equal YZ. And the third side DC, I see that are equal with LZ. And the last one AD or DA are equal with LX. So the first point, which is sides, all corresponding sides are equal in length. So I can't say that these polygons are congruent. I need to get the first and the second case, sides and the angles. I need to get both of them, sides and angles. If I only have the sides are equal, the corresponding sides are equal, but the angles are different, so I can't say that these polygons are congruent. I need to get the both of them, angles and sides. Okay? If I take the angle A, the corresponding angle in the another polygon will be angle of X. So measure of angle A will be equal measure of angle X. The next angle, if I take angle P like this angle, the corresponding angle of angle P in the next polygon will be angle Y. So the angle P will equal to measure of angle P will equal to measure of angle Y, and angle C will be equal the measure of angle Z, and the last angle, angle D, will equal the measure of angle L. All the corresponding angle are equal in measure. All sides, all corresponding sides are equal in length. So I can now say that the polygon A, B, C, D congruent with the polygon X, Y, Z, L. I say that this symbol is meaning of congruent, like this. Is triple lines not equal? This is called equal, but triple lines mean congruent. The first polygon A, B, C, D congruent with the polygon X, Y, Z, L. Remember that I say the vertex A first and the vertex BX first. Why that? I see that these two polygons are congruent, are equal. All sides, the corresponding sides are equal in length, and all corresponding angles are equal. Remember, I see the meaning of corresponding, only the corresponding. If I take this angle, angle A is not equal with angle Z. These are acute angle and these are obtuse angle, so they are not equal. I only take the corresponding angle, which is other. The corresponding angle with A is X, not Y, not Z, not L. So if I say that polygon A, B, D, C, in the other side, I will say that the same order, the same arrangement. I will start from A, then I will start from X, Y, Z, L. If you code that, if you put L before Z, it will be wrong, because L is not congruent with D. The first with first, second with second, third with third, fourth with fourth. All vertices are congruent. Okay? So we start from A in the first polygon. We must start in the second polygon with X, not with Y, not with Z, not with L. We start from A, then another polygon we start from X. If we start from P in the first polygon, then we must start in the second polygon with Y. We start from C, the another one we start from Z. If we start from D, though you must start from L. Okay? So this is very important. The arrangement, the order. We should write the two congruent polygons in the same order. In the same order of their corresponding vertices. Vertex A is a corresponding vertex with her is X. So A corresponding with X. P corresponding with Y. D corresponding with L. C corresponding with Z. This is the order of the congruent. Okay? Now I can see that A, B, C, D congruent with X, Y, Z, L. If I start from any vertex like this, I start from the vertex D. D and go on the right side, D, C, P, A. D, C, P, A. In the next polygon, another polygon, we must start on the same vertex, in the same corresponding vertex from D, which is L, vertex L. So we will see that L, Z, Y, X. Again, D, C, P, A congruent with L, Z, Y, X. It's very important to write any congruent polygon, any congruent polygon with the same order of the corresponding vertices. Okay? Another exercise, a polygon A, B, C, D, E congruent with the polygon X, Y, Z, L, M. These polygons have 5 vertices. Okay? He says that 2 polygons are congruent, complete. If these 2 polygons are congruent, I recognize that the sides AP are equal with sides, these sides AP are equal with side MX? No. ZY? No. Will be equal with XY side. Okay? AP equal to XY. The next one, PC are equal with, where is the PC? PC here. Are equal with side MX? No, with side ZY. Sorry, YZ. We start from P, so we must start from Y, not from Z. PC are equal with YZ. If you write ZY is wrong because we will take the corresponding side, the corresponding vertices, okay? So PC are equal with YZ. DE are equal, where is DE? DE here, are equal with ML or LM. DE, we start from D, so we need to start from L. Okay, DE are equal to LM. The next one, CD. CD are equal with ZL. We start from C, then we must start from Z. CD are equal with ZL. And the last one, AE equal with XM. All corresponding sides are equal in length. The next case will be the angles. All angles must be equal in measure. Angle A will be congruent with the same, are equal, the same with angle X. So the measure of angle A will be equal measure of angle X, and the measure of angle P are equal with measure of angle Y. Angle P are equal with measure of angle Y. Angle C are equal with the measure of angle Z. Measure of angle Z. Angle D, measure of angle D are equal with the angle of L. Measure of angle of L. And the last angle, angle E, this angle are equal with angle M. Measure of angle E equal to measure of angle M. So these polygons C, D, E, A, P. We start from C. In this point, we start from C and go up. C, D, E, A, P. Look to the arrangement, look to the order. C, D, E, A, P. If you take another polygon and start from M, no, you are wrong. Start from X? No. We start for the corresponding side with C. The corresponding vertex with C, which is Z. We start from Z. You will put Z. Okay? We go up or go down? We go up. We say that C, D, E, A, M, E, A, P. So we start from the vertex Z and go up. It will be L, Z, L. Next one, M. Next one, X. And the last one, Y. It will be Z, L, M, X, Y. Z, L, M, X, Y. So the polygon C, D, E, A, P are congruent. This symbol, as we said, at this meaning of the congruent, are congruent with the polygon Z, L, M, X, Y. The last case is called as special cases of their congruency. What's the meaning of special cases? If I have two squares, these two squares are congruent only if side lengths of one of them are equal with the side lengths of the other. What's the meaning of this? We know that any square, all sides are equal in length. So if I have any two squares like this, if I have this side length equal 4 centimeters and this side length equal 4 centimeters, I don't need to check the other side. I don't need to get a ruler and measure the other side to get this length and this length and this length. I have learned before that any square has the same length of each side. Okay, all sides are equal in length. So if I have square with a side length equal to 4 centimeters and another square with a side length equal to 4 centimeters. This is another case, a special case, that if I have only the same side length, I will say that these squares will be congruent squares. Okay? I don't need to check the angles. I know the angle of any squares are right angle equal to 90 degrees. I don't need to check the angles on the other side. I only need to get one side length. If one side are equal to another side in another figure or another square, so it will be a congruent polygon. Okay, the next one. If I have two triangles, their triangles are congruent if their corresponding sides are equal in length. If I have two triangles like this, if I get this side and equal to 3, this side equal to 6, this side equal to 4, and another one, this side equal to 3, and another 6, another 4, I don't need to check the angles. Okay, I don't need to check the angles in the both of these triangles. I only need to get the all sides, all three sides. If I get the corresponding sides and see that all sides are equal in length, so I will see that these triangles are the same. I will say that these triangles are congruent. Okay, I don't need to check the angles. These special cases make to me easily. Okay, in the squares I need to check only one side. In the triangles I need to check all three sides and don't need to get the angles in the square or in the triangle. And the last special case is in any two rectangles, if the length, L mean length, I have learned before that any rectangle has two dimensions, length and width. If the length and width, the two dimensions of one of this rectangle equal to the two dimensions of the other, I will say that this rectangle will be concurrent triangle. If I get this rectangle, this length equal to 4, this width equal to 3. If I have another rectangle like this, These lengths are equal to 4 and these widths are equal to 3. I see that these triangles are transformed like this. But the lengths of the first one are 4 and the lengths of the second one are equal 4. And the width of the first one are 3 centimeters. And the width of the another one equal also 3 centimeters. So I will say that these two rectangles are congruent. Why? Why didn't check the another rectangle, another side? I know the rectangle have two dimensions, length and width. If this length equal to 4, the opposite side here is also equal 4. And if I have the width equals 3, the first one, I know that the opposite side, which is another width, equal to 3. So I don't need to check the other side. I only need to get the rectangle. In the rectangle, I only need to get the width and the length. I know the rectangle. In the rectangle, all sides, all angles are equal in measure and equal to 90 degrees, the right angles. So if I have any two rectangles and I get two dimensions, length and width are equal in length, I will say that these rectangles are congruent rectangles. Okay? The special cases in the squares, rectangles, triangle. In the square, I need to check only one side. In the triangle, I need to check three sides. All sides of the triangle, I need to check all sides of the triangle. I don't need to check the angles. And the last one, in any two rectangles, I need to check the two dimensions, which is the length and width. Okay? These are special cases of the congruency. Okay, thank you.